today is seamlessly importing utilities from CAD to GIS. I know that many organizations rely on CAD files for their utilities, sometimes exclusively, and sometimes GIS is used in addition to CAD. So today we're going to look at some tips and tricks and converting CAD to GIS. I actually used to work for an engineering firm where this is a lot of what I did. So I have seen some really wacky CAD files and seen a lot of weird things that I've had to work through. But through all of that, I've kind of put together some best practices that I'll share along the way as we go today. So right off the bat, there are some key differences between CAD and GIS that I want to discuss and will kind of help us think about what GIS is doing, what we're doing as we're converting from CAD to GIS. So CAD, CAD, this stands for Computer Aided Design. And there are many different types of softwares that are CAD softwares, the most common being AutoCAD, MicroStation, Civil 3D. Then for GIS, the software that we're looking at today is going to be ArcGIS Pro. There are also other softwares that you could use like QGIS, but I prefer ArcGIS Pro because it has a lot of good built-in tools that will make this process a lot easier. As far as CAD file types, the most common are going to be DWG, DXF, and DGN. And these file types can all be read directly into ArcGIS, which is really nice for visualization. In GIS, the file types that we're going to end up with at the end of the day after the conversion has been done is a geodatabase file or .gdb. You can also use shape files, although the best practice when you're keeping all of your data in GIS is going to be to save everything in a geodatabase or GDB. All right, so some key differences. CAD, we're talking about layers. GIS, we're talking about feature classes. I know sometimes these can kind of get confused, and I've been guilty of that myself, of talking about layers in GIS. Really, they're just counterparts to the same kind of data that we're talking about in both softwares. So you can toggle on and off layers in CAD, you can toggle on and off feature classes in GIS. It's kind of how the data is structured. All right, so one key difference though in CAD with layers is that one layer can have points, polylines, and polygons all within one layer. But in GIS, we have to have separate feature classes for points, lines, and polygons. So this is the first big thing that we'll have to be thinking about as we go from CAD to GIS. In GIS, you're going to have more feature classes than you would have layers because of that difference in needing to have different feature classes for those different types of points, lines, polygons. And the last thing that I'm going to talk about, the last big difference, is that in CAD, coordinate systems are actually optional. So real world coordinate systems are optional, meaning that in CAD, you could have a drawing of whatever it is. You could have your start origin at 0, 0. You dimension your box or whatever it is you're drawing with the correct units, the correct lengths. But it could be essentially floating in space, and you can save that as your CAD file. But in GIS, that's not really going to work because we need to be able to tie our data to a real point on the Earth. And the way we do that is with coordinate systems. So we're going to talk about how you can use coordinate systems to get from CAD to GIS, how you can define coordinate systems. And I'll kind of go into how we do that here in a minute. So let's go ahead and get right into it. I'm going to spend quite a bit of time in this webinar in ArcGIS Pro today because it is kind of a hard thing to talk about unless you have something right in front of you. So I've got a few different maps up in here, and I'm going to start with a map of Roanoke, Illinois. And I've got some data from their utility CAD file. I've already got it in here symbolized kind of nicely, so I'll click this on. And you can see some data pop in here. It looks pretty good. The utilities seem to be lining up with the roads. That's a good indication that things are in the right spot. I've got this nicely symbolized, so we have different colors for different lines, for different points. Over here in my contents window, something that I want to point out is that I have a polyline group here, and I have a point group here. And in my polyline group, I have this VUtil water P. So it's some sort of water utility layer that I can click on and off. I also have the same layer as a point. I think there's only one that's clicking on and off there. But so basically in CAD, this would all be in one layer. In GIS, we're seeing it in two spots. We're seeing it as a point and we're seeing it as a polyline. So this would be like, this would be your water mains, and this would be your manholes or some sort of other point feature that is what you would use in GIS going forward. So this is CAD data brought right into GIS. And if I was to look at it, it'll look pretty similar to how a feature class would typically look if you're bringing in an actual feature class into ArcGIS. You can open up an attribute table. You can select features. You can select by attributes. You can query data. But what you can't do, because this is a CAD file, is you can't edit anything. If I was to select one thing, the delete button is grayed out, so you can't do anything with it until you actually go and convert it. So let's go ahead and walk through that process. So I'll open a new blank map, and I'm going to navigate in my catalog pane to my folder here that has a couple of DWG files, of CAD files. And if I open this one up, it'll show, for every single CAD file, it'll show these 5 things. It'll show annotations, multi-patch, which is 3D. So we're not really going to go into a lot of that today, but it is possible to convert. And then points, lines, and polygons. So this will show up, like I said, in every single DWG file that you bring into GIS. So this is kind of a simple one. My actual data looks a little bit more confusing, but the good thing is it still is going to have the same annotation, multi-patch, point, polygon, polyline layers that pop up in here. And this is all that you need to worry about when you're converting from CAD to GIS. Everything else, all of this stuff that looks like it's extra, it looks like you're leaving some stuff behind, it is actually all incorporated into these 5 layers. So I'm going to go ahead and add these to my map. And we can see that they come in over here on the contents, but there's no data here, which is concerning. And we also get this error up at the top that says unknown coordinate systems. So if I go ahead and I try to zoom to my data, it does exist somewhere on the Earth, but it's not in the right spot. It is actually popping up in Africa, which means that I have a coordinate system issue. So let's go ahead and fix that. I'm going to open up this polyline group here. And when I do that, it's going to look really busy. But basically, all this is doing is it's taking all of the layers in CAD. So these are all of our CAD layers that have a line feature in them, and it's putting them here. I'm going to click on one of them to view the properties so I can look at some information, some source information. The data type is going to be CAD feature class. We know that. We're still working with CAD data. The spatial reference down here, that's key. So this says unknown coordinate system. So we need to define this coordinate system so that our data pops up in Roanoke, Illinois, instead of somewhere in Sudan. So I'm going to go to my geoprocessing tools. I have this kind of stuck to my right side of my screen here, but the way you access this is through the analysis tab. and then you just click this tools button and this geoprocessing pane should pop up. I am going to search for a tool called Define Projection. And I am going to input my entire CAD file, which is this guy. And now I need to tell it what coordinate system it should be in. So right now it's unknown. As we checked the data property, the layer properties, it told us that it was unknown. So how do we figure out what coordinate system to put it in? The best way to do that is to just go ask the person who gave you the CAD file, who made the CAD file, and hopefully that they can tell you. I would say from my experience, about 90% of the time, it's going to be a state plane coordinate system because that's really good for engineering purposes. It minimizes distortion. So my CAD file, I know, is in state plane Illinois West. So I'm going to select that. And then I will hit run. And then I'll run for a second. And something that I've noticed is that once this runs, you have to reload this data. So I'm going to remove this for a minute and re-add it, and hopefully it will appear in the correct spot. So I'm going to add, again, my annotation, my multi-patch, points, polygons, polylines. And let's go ahead and add that in and see what happens. All right, it'll take a second to load and to zoom to the right spot. All right, but that looks a lot better. It looks like we're in the right spot here. So that's great. Everything we have done at this point, we are still using the CAD layers. We have not yet converted to GIS. But just to kind of show what happens when you run that define projection, not only does your data move to the right spot, in our file explorer, where I have this file. So this is my DWG file here. What I have created now is this PRJ file or projection file. And this is a text file that is going to tell, if I was going to open up this DWG file again in a new ArcGIS Pro file, it will always have this PRJ connected to it. So from now on, as long as these two files are in the same folder, this CAD file will know to have the correct projection that I just assigned. All right, so how do we go about actually converting? I am going to just keep my lines on so we can simplify this a little bit. So we've got our lines here. If I open up this polyline group, again, we can see all of the layers as they are named in CAD. If I just needed maybe this water layer here, let me select it. Maybe this is the only new data that I need to get into GIS. You could simply right-click it, go to Data, Export Features, name it whatever you want, save it in your geodatabase, and bam, you're done. And you have converted from CAD to GIS. There's a few other ways you could do it. If you needed multiple of these layers converted, you could use a tool called Feature Class to Geodatabase. And although this tool is called Feature Class to Geodatabase, it actually sees CAD layers as feature classes, so this tool will work. So if I wanted to select, maybe I need these three utilities, I would input them, and then I would save them to whatever geodatabase and run it. And let's go ahead and run this one real quick. So I'll put it in my folder here. And it will convert those three pretty quickly. There's one done. 2, and 3. Perfect. And now if I go to my geodatabase, I have those 3 pop up in here. Lastly, a little trick that I learned, especially when you have a CAD file that has a lot going on with it and you kind of want to see everything in GIS that you can determine what's important or what's not. We have, when you load CAD into GIS, for every point annotation polyline group, the first layer that's put in here is going to be a combination of all of the individual layers thrown into one layer. And this is pretty neat because if we look at the attribute table for this data, it has a field called layer. And this is what we're going to use to be able to create an individual feature class from each one of these different layers. And there's a tool for that. So thanks, Esri, for that. It is called Split by Attributes. And this is a really cool tool, not even just for this process, but I've used it to save me a lot of time for other workflows that I've been doing. So if I input this polyline group and I say target my geodatabase workspace and split it by that layer field that I was just looking at, I can run this and it'll take just a few seconds here. I can run this and it'll grab all of these different layers and put it into my geodatabase. So we'll give that just a second. And I'll clean up some stuff in the meantime while that runs. Almost there. All right, perfect. So let's go ahead and refresh our geodatabase. And now we've got a lot of stuff in here. So this is perfect. I am going to add these all to my map. The nice thing is they're all named the same as my CAD files are. They come into the right spots. And if I click on the properties of these GIS files, because this was the conversion spot, the turning point where we went from CAD to GIS, we have the data type is a feature class. We have the spatial reference, which is State Plane, Illinois West. And so now we are pretty much good to go. So you can take whatever layers, well, these are now feature classes, take whatever feature classes you need to use in GIS, whatever tasks you need to move further with. These are ready for you to go. If I hop back into the symbolized version of this data where I grab just a few different types of utilities, this is kind of how it can look when it's all symbolized nice and pretty and ready for more of whatever you're going to use it with for GIS. So that is one way you can convert from CAD to GIS. It is kind of the step-by-step method to do it, but as I was researching for this presentation, I found a better way to do this. And so I'm going to hop into a new map. And I am going to use a tool that's going to do everything that I just did when I went from defining the projection to exporting it to getting all of those different feature classes. We're going to do that all in one go. So we're going to use a tool called CAD to GeoDatabase. I am going to input my CAD data. And I'm going to actually use a copy of my original data because the CAD file that I was just using now has that projection file in it, and I kind of want to start from scratch. So this one is the kind of bare CAD file without any projection defined. There goes my CAD data. I'm going to put it into my geodatabase. And then this line for data set, this is going to create a feature data set within your geodatabase. So this is kind of like a subfolder within your geodatabase. And basically everything that's in this feature data set is going to share some properties So everything in this data set has to have the same coordinate system, for example, and there are some other nice features that it gives you as well, but that's the main one. I'm going to call this data set CAD to geodatabase. And I'm going to give it a spatial reference of the state plane Illinois West coordinate system, because that's what I know my engineer told me to use. Go ahead and hit run. And I'm going to get an error. I wanted to show this step because I did this as I was working through it. When you create a featured data set, you can't have any spaces. So I'm just going to replace those with underscores and run that. And it'll think for a minute, but it's taking my CAD file, giving it a projection, and putting it inside of my geodatabase. And it should just take a few seconds. But of course, it always takes longer when you're presenting, so I'll give it a few more seconds. There we go. All right, so now I'm going to refresh once more for my refresh my geodatabase. This is all the data that I created the first time that I ran through this process, but now I have this new icon, which is my featured data set, my CAD to GDB. And I've got 5 feature classes in here. What might look familiar is I have points, polylines, polygons. I don't have annotations and I don't have multi-patches because those actually don't exist in my particular CAD file. But if they did, you would see those pop up here. So I'm going to add these 3. These 2 you could probably delete once you confirm that all of the data from these 2 is actually within the points and the polylines in here. I believe it is, but always good to double check. I'm going to add these in. I'm actually just going to start with the polylines. I'm going to zoom to that. And we are kind of ready to go. So everything is in Roanoke. Let's check and make sure that we have our properties correct. So we have a feature class. We have our spatial reference that is correct. And there we go. So what I would do from here is I would again run the split by attributes tool. And I would just do that for all 3 of these feature classes that I have in here. And that will create the same kind of thing I was talking about before, where we have in the attribute table, we have a field for layer. So every unique layer will have its own feature class created. And I'm not going to run that one again because I know it took some time last time, but that's basically it. So that is how you would go from CAD to GIS. And so let me hop back into my presentation. So in summary, I just wanted to put up the tools that I used today in GIS. They were define projection, not determine. That's a typo. Sorry about that. Define projection, CAD to geodatabase, and split by attributes. And with those 3 tools, you should be able to handle any CAD file that's thrown at you. If you need more support on this, we're always here to help. And we have actually done this process for a client who had a lot of CAD files to convert. And we were able to create a script that was able to convert a lot of CAD files according to this client's specific needs. And they were able to convert files in just minutes, and something before that would take them hours to do. So if that's something you need to get your utilities from CAD to GIS, we can definitely help, and would love to chat.